Hey everybody, my name is Jay Gordon. Welcome back to the Azure Cosmos DB user group, and this month is it's September. Wow, this year has moved by so fast. We've had so many great sessions that myself and my friends from the Reactor have been able to bring to you. I'm really excited about today's, and mainly because it is a subject that is near and dear to my heart. And we'll talk about that as we bring our guest in and we start talking about our session and what he'll be showing us today. But before we all do that, I want to bring him on. I want to bring on our member of the Reactor team, Askia. So first, I'm going to bring in Askia. Hi, Askia. How are you today?
Good. How are you doing?
Great. So we are back here. And I'm really glad I've got you as one of my compadres, my teammates, the people that's helped me put these sessions together. Yes. And when we do these sessions, it's important for you to always share with us some of the housekeeping. So I'd love for you to kind of roll through that, and then we'll get into our guest in our session.
Absolutely. Well, hello everyone. Thank you for joining us for today's session. My name is Askia, as Jay mentioned. I am the facilities coordinator for the Redmond Reactor space. And before we get started, we just have a few tidbits to go over. So please take a moment to read our code of conduct. We seek to provide a respectful environment for both our presenters and our audience. So we encourage engagement in the chat, but please be professional, remain on topic, and be mindful of your commentary. We will share useful links throughout the chat, so keep an eye out for that. And the session will be recorded, so it will be available on demand on our Microsoft YouTube channel within 24 to 48 hours after the session. And that will run for approximately an hour today. And that's going to bring us to today's session with our speakers. So I will let Jay take it from there.
Thank you so much. Appreciate it. And we'll see you at the end of the show. So today I've got a really great guest, a guest that I've been waiting to speak to for a while, and here he is. I've got here David Sanchez, and you are a DevOps consultant at Xpirit, correct?
Yes, that's correct. Yeah, I work at DevOps Consultant at Xpirit. Yep.
Wonderful. Well, thanks for being part. And today we're going to be talking about DevOps. And like I said, this is a subject that's near and dear to my heart. I was a DevOps engineer. I was a DevOps cloud advocate for years. Got to work with some of the best people that I know have done DevOps, like your Donovan Browns and your Abel Wangs and Jessica Deans, all these people that I can say I've known that have worked and externally. There's so much great DevOps content out there. And today you're going to talk to us about utilizing DevOps practices for Azure Cosmos DB. But David, before we start getting into your session, I really want to know a little bit more about you. So I always like to give this kind of loaded question of how did you get here today? But it literally doesn't mean how you walked into your office. It's how did you get into being here and speaking with us today? What was your road into technology?
Yeah, absolutely. So thank you very much for having me. It's great to be here. I started my career as a consultant. I started computer systems engineer and always passionate about helping others be more productive, collaborate more. And that's how I got into my previous part of that career that I started with SharePoint Office 365. I was part of the Microsoft Most Valued Professional in SharePoint Office 365, and I basically start developing a lot of custom solutions. Later on, I started with .NET, and I realized that I was basically helping a lot of developers being more proactive with their solutions. So that's how I got into the DevOps when it was known as an ALM. Later on, I was part of the ALM Ranger program.
Mm-hmm.
And then I started working at Microsoft. I stayed at Microsoft for 7 years. And last year I started at Xpirit. Right now I am back in the MVP program in the developers category. And basically working a lot with GitHub solutions and doing DevOps and automating things and helping customers and developers being more productive. And I have seen a lot of databases practices, DevOps practices for databases, and that's why I'm here. So yeah, thanks for having me.
You're welcome. I've definitely seen, I think there's like a DevOps for Databases O'Reilly book that I remember reading like a million years ago. I think it was by like Charity Majors or something like that. But great. I am really, really interested in hearing what you have to say today. So just as like an aside, I have been playing with GitHub Actions a lot lately. I've been trying to get some applications built and have an end-to-end deployment. And a lot of times, that's what this is all about. It's about end-to-end deployment, being able to make it so that your whole process of building resources, going ahead and building whatever your application is, deploying that, and being able to do it basically repeatedly without having to worry about any of the manual work. That's always what like DevOps has been about me. It's about, being able to implement automation. It's about creating a culture of sharing and involving more than just one team, having a multitude of teams work together in order to accomplish our goals of like producing the highest quality work. So
yeah, exactly. As you mentioned, basically it's a end-to-end solution. Is not like some specific practice. For this session, what I basically prepare is some of these practices that are basically part of the DevOps. But as you said, DevOps is huge. So we will be focusing more on some of the practices can be applied to basically Cosmos DB in this case.
Great. So I think what we should do is, why don't you go ahead and get what your deck is going to be, so you can talk to us or talk to us about your agenda, and then I'd love you to go into what you're going to show us today. So I'm going to just let you go ahead, bring up your first slide, and then we'll get running.
Perfect. Yeah. Well, for this session, I only have one slide that is basically the agenda. So these are the practices that I will be focusing on. The first one is kind of basic. It's just version control on stored procedures, triggers, user-defined functions, and so on. It's kind of basic, but I have seen so many customers and developers basically deploying scripts directly to the databases without tracking what's the history of these scripts, what they are doing with the data or the data structure. So the first part is how to use GitHub in this case for keeping version control of these scripts that I mentioned. The other part is infrastructure as code. Basically, it's how to deploy the Cosmos DB resources in a automated way with, in this case, ARM templates. But the same practice can be applied with Terraform or Bicep. The other is the automated testing with Cosmos DB emulator. This is a great tool if we don't want to deploy an Azure Cosmos DB service and basically do some local testing. So that's the other way of how to automate these tests. And then the part that will involve more GitHub Actions is the CI/CD to automate these continuous integration, continuous deployment tasks. So with that, as mentioned, what I prepared for this session is a GitHub repo. It's public, it's live right now, and yeah, it will have the code for all these practices. So let me share my browser here. Okay, so yeah, this is the repo. As you can see, it's under my account, Sanchez / DevOps practices for Azure Cosmos DB. And from here, you can see that I have a workflow file. I have the infrastructure as code, like I mentioned, ARM template. I have a sample application, a web app application built with .NET 7, stored procedures and triggers. I will go through some of these basically files, like the code owners. And for the README file, you can find here basically the status of the workflow that I have, the GitHub action workflow, and the link of this session and how to deploy basically the Azure resources that I have, in this case, manually, if you don't want to do it through the CI/CD workflow. All right, so just to do like some basics for those of you that might not be familiar with Cosmos DB emulator, this is basically a tool that you can download, install. In GitHub, we use the GitHub runners. These are basically the agents that we use to run all the automated tasks that we have. So part of the tools that are already pre-installed in the runners is a Cosmos DB emulator. So we can use basically the runners that we have available in GitHub to run the different testing that we need in the Cosmos DB emulator. As well, we can use it locally to develop, but yeah, in this case, we will be using for testing. Next, we have a CI/CD workflow with 4 different stages. In the first part, we have the build the .NET web app. Then we have the QA environment. This is using basically QA subscription in Azure just to test everything before going to production. Next, we have the production environment, and it's basically deploying its own resources, and we are deploying the scripts that we have for yeah, this environment. And then we have the testing with Cosmos DB emulator. So this is something that yeah, it's not part of the workflow, but it's something that we have as well as part of the CI/CD. In the GitHub, we have the environments, as mentioned, production and QA. So we can set up rules for these environments. In this case, if I go to the settings of my repo, environments, I can see that in production, I have 2 protection rules. The first one is that when I go to deploy to production, I can define who are going to review basically these deployments. In this case, I have myself as a reviewer. I can allow it, admins can bypass this configuration. And also, I can define which branch is allowed to deploy to production. In this case, only my main branch can deploy to production. This means that if I have another branch and I create a pull request to basically deploy to production, it needs to be merged and so on. So I can define other settings, like, for example, environment secrets, environment variables. In this case, I need to make sure that all the resources that I'm going to deploy to Azure are only in my production resource group. So that's basically one of the variables that I have here. The same with the QA environment. For QA, I can define the reviewers, wait time, secrets. In this case, the only variable that I have here is the QA resource group. And I also have some secrets and variables at the repo level, not per environment. These are basically things like the Azure subscription ID that I'm using for this demo. probably in a more real-world scenario, I will use different subscriptions for my QA and my production environment. Also, I have the Azure credentials. This is a service principal that I'm using to connect or to deploy from GitHub to Azure. And then I have the service principal ID that is basically the client ID that I'm using to deploy.
So, David, these all are able to be, and if just based on what I know, and I just want to share this for our audience, these all can be referenced as variables within our action. And if those of you who don't know, our actions are written in YAML. And so for those of us who know YAML, it's pretty typical. But if you're not the biggest YAML expert, I can say that it reads pretty simple. It's mostly about understanding the linting and the formatting.
Correct. Yeah, exactly. Yeah, these are features that are available for free. In this case, I have a public repo, so all the actions minutes that I have are available for free. The environments, the defining secrets for the environment, the repo level. Yeah, these are basically features that I have available as part of the GitHub Actions. GitHub Actions is, yeah, as you mentioned, this product that enables me to create a workflow to automate tasks, like, for example, the CI/CD. And yeah, we will take a look at the YAML file that you were talking about. So
sure. Yeah. And just for everybody, if you're still new in development, you're curious, CI/CD, it stands for continuous integration and continuous delivery or deployment. It's about creating tools to be able to have your code go into your production environment or even your development environment without you having to go and manually do any of the work. There's processes that you'll see here in GitHub Actions, and GitHub Actions is a great CI/CD tool built into our repository service, GitHub. And you can create these workflows. And David, I know you're going to be showing us that, so I'll let you continue. Thank you.
Yep.
And everybody, if you have questions, please put them in the chat, and we'll try to get to them as soon as we can.
Yep. Excellent. So yeah, as you mentioned, the requirement for the YAML files are that needs to be stored in this path under .github/workflows. So that's where I have my YAML file. I can have multiple YAML files. In this case, this YAML file will be triggered when there is a new push in the main branch or there is a pull request against the main branch. I have the name of the workflow, and then I have the different jobs. So before going to the jobs, I want to explain a little bit the stored procedures that I have here. So as mentioned, the idea of using GitHub to keep track of all the different server scripting that I have, like in this case, triggers, stored procedures, is that I can track basically the history of these files, know what I'm doing against the database. So in this case, I have this very simple stored procedure. It's just responding with the body message saying, hello, Azure Cosmos DB, and that's it. I'm using the Node.js SDK to create these stored procedures. So yeah, as you can see here, what I'm doing for creating this stored procedure is just defining an ID that is basically the name of the stored procedure, and then the body is basically the function, getting the context of the stored procedure, and then the response, and then replying back. What I did for deploying these scripts is to create another function that basically takes what endpoint do you have, what key, what database ID, container ID, well, basically where you want to deploy your stored procedure. Take the stored procedure file, and then basically if you want to do a test for this stored procedure, and here basically if it is against the Cosmos DB emulator, the local host, it will disable the TLS verification. This is because Cosmos DB use their own self-service for the SSL certificate. So we are going to disable that if it is basically against the Cosmos DB emulator. Then we define basically the Cosmos client. We pass the endpoint and the key. Create the database if not exist, same with the container. Then we load the stored procedure file. And from these, we create the store procedure. If it exists, if we get an error 409, it means that exists. So we replace it with a new version. And if we want to include the test, basically we pass some results. We call the store procedure, execute it, and then basically log the results. And then this is just validation that we are getting all the parameters. And this is basically the execution where we call the function. We pass the endpoint, database, and so on. So same with the triggers. It's the same structure that I did here. So we have the sample trigger. This is basically just adding a timestamp to the document that we are loading. The trigger basically can be executed before it's inserted into the database. So in this case, it's before. And yeah, what kind of operations? In this case, is supporting all the operations that we have in Cosmos DB. And yeah, we load the document, added the timestamp, and that's return. So the process to create the store procedure is the trigger is the same. We get the endpoint, key, database, container, trigger file, and if we want to do the test, and then we validate if it is localhost, create the database, create the container, and then create the trigger same way. And then if we are doing the test, we create one new item, add it to the database, and then basically log the result. So that's basically what we will be using in the workflow. For the provisioning, what we have here is one ARM template. And this is important because in Cosmos DB, we have many options, so many configurations when we are creating the resource. The idea of having like an ARM template is that we can create the resources that we need in Azure exactly the same way, so consistent between different environments with the different settings that we have available. In this case, we are creating the resource. It's just using the minimum required properties. So we have here the collection, the location, the offer type. In this case, if we want to use the free tier that is offered in Cosmos DB, and then we create basically the server for the app service plan, the web app, and then we added the configuration to add the default connection, so the web app can connect directly to the Cosmos DB without me having to manage like some specific configuration for adding that connection. So I don't have to deal with the keys or string connections or things like that. And then for the outputs, we have the database endpoint, the database name, and then the web app name. These are used in the YAML file in order to deploy and to connect to the Cosmos DB. So another thing that I want to mention about GitHub is that there is code security and analysis. These are features that are completely free in the public repos. So, for example, I have the private vulnerability reporting, dependency graph, Dependabot, to scan all the different packages that I'm adding to the my solution. I can do as well security updates. If I want, the Dependabot basically can open pull requests if there is like some package that needs to be updated. And also we have code scanning for basically find vulnerabilities in my code. And we have as well secret scanning. So secret scanning, it's GitHub will scan all the different repo that I have here, all branches, and will detect secrets key and author tokens. And this is basically through the partner patterns. So basically, Cosmos DB is part of this program, and GitHub will identify if I have like any connection string that is basically that could be a potential leak in my source code. So it will trigger basically a flag saying that I have a possible connection connection string in my repo. As part of this feature, we have push protection that is going one step ahead And instead of allowing developers to commit secrets in the repo, I can block these commits. So if for some reason I basically, as a developer, push some commit that contains a secret, I will get blocked, and basically I will receive an error. So that's something important to basically using DevOps practices when we are developing solutions with databases, because we don't want to expose those secrets in the code repository, especially if it is a poorly repo, like in this case. Okay, so just to show you an example of that, if I go to GitHub here, GitHub Desktop, and I created a new branch, let's call it test. Okay, the test branch, and then let's publish this branch. Now I am in my test branch. If I go to Visual Studio here, and I have my app settings, let's replace this local Cosmos DB basically connection to the Cosmos DB emulator with the real basically connection from my QA environment. I will save this. And if I go back to GitHub Desktop, I can see here the change. So update app settings, that's okay. I'm going to commit that. And now I'm going to push this to the origin. So as you can see, this is basically the error message that I'm getting, saying that there is a Cosmos DB key identifier. And basically, I need to remove this secret in order to commit or to push this commit to the repo. So that's part of the configuration that I can have at the repo level. So if I go here, let's refresh.
And David, I have a question for you here.
Uh-huh.
I've dealt with having accidental credential commits. If I am a developer and I have this happen, obviously it's going to remain in my commit history. What would I be doing to make sure that that these credentials are removed, aside from just rotating the key that you may be using?
Yeah, that's a great question. So the first thing is that if you don't know that happened, basically you will get in the security tab, you will get a flag in the security scanning saying that there is a possible secret exposed. From there, you can have like three different options to close or deal with that flag. The first one is to basically just dismiss the alert by saying that there is a false positive. It's not like actual secret. It is something that you already revoked. Basically, it's something that you, as you mentioned, you rotate the secret, and that secret is no longer valid. And the third option is basically by going to the commit history and try to do like a git commands, more like advanced commands to remove that commit from the history. Although it's not recommended if it is a valid key, because there might be still in the history. But there are some git commands that you can use to remove that commit from the git history. But the recommended and the fast approach is basically to rotate the secret as you just mentioned.
Yeah, I think there's like Git filter repo, which is one of the like pip-based tools that you can use. Like, I think you just pip install it. It's as a Python module. I have definitely become more vigilant about making sure that any configurations are related to a connection string are removed. Like, it's good practice, and it's great that a service like GitHub and GitHub Actions specifically allow you to use things like Dependabot and secret scanning. Anyway, I'll let you get back into it. Thanks.
Perfect. Yeah, thanks for the question. All right, so let's explore the code that I have in the YAML file. As mentioned, we have here the name of the workflow, and then we have the jobs. For the jobs, the first job that we have is the build. So we are building the .NET web app. For this one, we need to specify the name of the job. We need to specify where it will run. In this case, we are using the GitHub hosted runners. In this case, it's Ubuntu latest. Then we have the steps. And here we define like all the different steps that we need to run in order to complete this job. So the first one is just checking out the repo. So cloning the repo, downloading the repo into the runner, the server. Then we set up the .NET version. In this case, as mentioned, is .NET 7. We run the .NET restore, .NET build, publish, and then we upload the artifact, that is the basically the output from the publish, through GitHub. And the next job is basically testing. So this is testing with the Cosmos DB emulator. We want to make sure that the stored procedures and triggers that we have are running against different environments. In this case, I can test it locally. And also I can use the Cosmos DB emulator to run this test. So the first part is initialize the Cosmos DB emulator that we already have pre-installed in the runner. This code is from Microsoft Learn. So basically what we are doing here is running a PowerShell script to initialize this emulator. So no firewall to avoid like any network connection, and no UI because basically we are running it in the GitHub hosted runner. So it's everything is through the command line. And then we get basically what's the emulator base name, what is the version, the endpoint that we have. As you can see here, basically the Cosmos DB emulator supports the different APIs like Cassandra, MongoDB, Gremlin, and so on. So we get the IP, and that's pretty much. Next, we set up the Node.js. As mentioned, I created these stored procedures and scripts with the Node.js. So we installed we set up the Node.js version, in this case with the latest one. And then we install the dependency. We need to install the npm package for Cosmos. Then we call basically the node stored procedure that we have, that create this stored procedure file. We pass all the different parameters that we saw before, like the endpoint, the key, the database name, the container, and then basically the file that we want to add. And this is basically to include if we want to do testing or not. So if it is one, it will execute the test. And then that's basically for the Cosmos DB emulator. So let's take a look at the result that we have here. So if you go to the Actions tab, we can see all the different runs that we have. In this case, I will open the latest one. And we can open for the build.net. Basically, it's doing all the steps that I mentioned. So this is creating the package that we have here. Sorry. We have this artifact. This is basically the .NET application publish that we created. And for the testing with Cosmos DB, we are adding these steps that we have here. So for initialize the Cosmos DB emulator, takes around 2.5 minutes or 3 minutes. And these are basically the different values that I was mentioning, like the version, the name, the IP, and so on. So you can see that basically now the Cosmos DB emulator is running in this server. Something important that I didn't mention in this environment is that we need to use the Windows latest version, because right now Cosmos DB emulator only supports Windows. You can run it through Docker in Mac or Linux, but right now it's that is on preview. So I left the link here to how to do that. But yeah, for this case, I'm using the Windows hosted runner to basically run that this set of tasks that I have here, steps. So here we are creating the store procedure because this is a local environment. You can see here that I'm getting a warning saying that the verification of the certificate is not secure. So that's okay. It's a local environment. It's a Cosmos DB. And then I'm getting the result back from the console. Same for the trigger. So here I can see the item that was created, and I can see that we have a timestamp. So that's good. And that's pretty much. So for this environment, it's basically just that part. And then for the QA environment, it's basically doing the same. It's creating the environment for the QA. It's using Ubuntu. We are just cloning the repository checkout. Then we have the Azure login because we are connecting to the QA environment in Azure. We create the Azure resources. In this case, the resource group is created in the East US. We can put a parameter for the location as well. We have the provisioning Azure resources. Something that I wanted to highlight is that we have parameters for each different environment. So the environments are created exactly the same. What changes basically the name, the different web app tier that we have. So it's exactly the same environment, just with different settings and tiers. In this case, for the QA environment, I'm running the web app in a basic plan. And for the production, it's basically running on the standard one. Yeah.
So, David, we have a question from Xpirit, and I'd love it if you don't mind answering it. Can your technique of creating a script to create the trigger be used with a compiled C# trigger?
Yeah. In this case, I use the Node.js, but you can use C# to create basically the trigger or the store procedure. Yeah.
Great. Thanks a lot. And everybody, also, if you're watching and you have more questions, just drop them in the chat and we'll try to address them as soon as we can. David, you've got about 20 minutes or so left in the hour. If you don't mind, go ahead and keep rolling on.
Awesome. Then we are provisioning the Azure resources. Then we have the get the Cosmos DB key. So this step is to avoid dealing with the connection stream. So manually. So what we are doing is through Azure CLI, we are getting the key. Something important here, and this is a feature part of the GitHub Actions, is that I have the option to add a mask. So in the logs that I run in the GitHub Actions, I won't be able to see the real or the actual value of this connection string. So this is basically hidden in the logs. What I mean with that is if we go back to the GitHub Actions, and I can see basically the logs of this execution. So for the get Cosmos DB, you can see here that I am executing this parameter here. What I have is basically the name of the Cosmos DB, the resource group. We can also put a mask on that, on those parameters. In this case, I'm just leaving those there. But for the actual key, since we are adding the mask, I am not able to see the value. In the when we call basically the connection here, this is basically what you see, because that value has a mask. So I'm not seeing basically what's the connection key. If we compare that to the Cosmos DB emulator, here you can see that I am using this key, and that is because this is the default key of the Cosmos DB emulator, so it's not actual like a potential risk of exposing that. So that's another feature of GitHub Actions to be able to mask these secrets that I have. Next, we set up the Node.js, and I installed the dependency, and we created the store procedures. Same with the testing, because this is a QA, so we need to make sure that these values are are respected, the results. And we download the web app, and then we deploy to Azure App Service. Same for production. The only difference with productions is that we, for the store procedure and trigger, we are not doing testing in this environment because we don't want to add values that can basically affect or have any impact on the production data that we have there. So this is basically the YAML file that you were mentioned. We have these 4 jobs. Because we have this file with the workflow dispatch, we can run this manually. So if I go back to the actions, you can see here that I have the option to run this workflow. If I have multiple branches, I can decide which branch I want to use to run it. Or in this case, basically, I can define if there is like a new branch that I need to run. I can define where I want to run it. So one cool capabilities of this is that I can see the live logs while this is being executed. So for example, for build.net, I can see that in this case, it's basically setting up the .NET version, is running right now the .NET build, and so on. So same for testing with the Cosmos DB emulator. As mentioned, this task takes around 2.5 minutes, 3 minutes. So this might take a little longer. Yeah, we have here this now workflow basically being run. So we have just completed the first part of the job. Now, because we have the dependency of the QA environment, we have the QA now running. It's basically setting up the job. And you can see that we can run parallel jobs, like in this case. So, okay. Something important here is that we can have protected branches. So if I go to the settings, branches, I can see that we have protected branches. So in this case, for the main branch, we are requiring to have a pull request before merging, require approvals, require review for code owners. Code owners is a file that basically will allow me to add people to be automatically added as a reviewer for pull requests, depending on the files. So if we go to the code here and we open the code owners, I can define basically who are the code owners for each specific files. In this case, I only have myself, but the idea here is that I can add other users or teams. So for example, for all the different YAML files, I can define like a specific user if I am updating the workflows. So they will be added as reviewers for all the changes that I'm doing to these files. Same with JSON or C# files. So that's something that I wanted to cover for code owners. Also, here I can define if I need the signed commits. This is an extra security for the commits. So this is just to verify that I am adding code as with a signed commit. So it's basically verify commit. If I go to the code here and take a look at the commit history, you can see that all these are basically verified. So these are signed. This is just that these basically commits are signed with a certificate. In this case, if I want to enable this, I can go to my user, then settings, and from here I can add the keys that I need to basically create these verify commits. So, okay, let's see how we are doing this one. Okay, just go back. Okay. So it seems that the testing with Cosmos DB is still being executed. It initialized the Cosmos DB emulator successfully. So now we are basically creating the test procedure and trigger as well. So yep. Now it basically completed, executed. And for production, because I added the reviewer, I need to approve to make sure that basically this is good to go. So this is a good way to make sure that everything that was deployed to QA, it's safe to deploy to production. So if I go back to the action here, I can see here that basically this is waiting for my approval. So if we need to change that, I can go back to settings, environments, production, and from here I can specify who will be required to review this deployment. I can set up a wait timer as well, and other options. In this case, let's go back to the execution. I want to make sure that my application in the QA is good to go. Also, I can make sure that the scripts are basically returning, time stop. I can see here. And also for a store procedure, I see that it's basically getting the value that I was expecting. So yep, it's good to go. Now basically opening my application, I see that I have the data expected, the application loaded correctly. I can create another item here. Oops. I click on the backlist. Okay, great. Yep, it's expecting, it's basically working as expected. So yeah, it's good to go. So now I can go back to the production and say that, yep, it's ready to move to production, approve it, deploy. And now basically this deployment just started. And I will get the same values for production. The only difference is that for this environment, we won't be doing any test. So yeah, that's it. And that's basically what I have. I don't know if there is any other question.
Right now, no other questions. So if you want to go ahead and start wrapping up, or you're just going to leave this running, more than fine. It looks like you're just running through your production deployment that's just going to go ahead and throw everything together. So we've learned a ton about DevOps, implementing DevOps practices using GitHub Actions. And I know that there are more ways of handling actually the infrastructure build. So we could use Bicep, and we could actually kick off a Bicep deploy from our workflow in GitHub Actions. You set up some credential things within GitHub Actions, like David, you showed before, where your login information, subscription, and you go ahead, you can create the resources you need, and then eventually run your deployment. You can make it part of one giant workflow. Anyway, David, I'm going to bring in Askia so we can go ahead and close out our session. I'll say goodbye to you in just a minute, but first I want to say goodbye to Askia. So I am going to bring up your slide and just mention that we did share in the chat this particular survey, so you can click it directly. But why don't you take it from here?
Yeah, thanks, Jay. And thank you all for joining. Thank you to our speakers. Thank you, David. Did an excellent job. And just like Jay mentioned, we would love to hear any feedback that you have on the session or any future sessions. So the link can be found on the screen. So please go ahead and take a few moments and fill that out. And until next time, I thank you and appreciate your time.
Great. And so, David, I'm going to bring up your slide once again. If people did not have their question answered today, they can get in touch with you. And it looks like you've got plenty of places for them to do that.
Yes, that's right. So again, thanks very much for having me. More than happy to follow up with any questions. You can find me in social media as dsanchezcr, or in my website and blog, dsanchezcr.com. So it was a pleasure to present and share this topic with you. Thanks very much for the attention.
Spectacular. Well, everybody, it was a great session. I think we learned a lot today, and we will be back again next month. We're going to look at Postgres. We're going to look at vector search. We've got a really great guest. I can't wait to introduce you to her. But until then, I will see you next month. Thank you to David. Thank you to Askia. You both have been great. And so I'm going to ask you both, let's give everybody a big wave goodbye. We will see you next time here on the Azure Cosmos DB Global User Group. Until then, have a great rest of your day and week. Bye now.